West. Wait, are we filming
Yes.
now? All right. Now, so for the Southwest kids and East End and North Central, test is tomorrow. Yeah, leave the quizzes in the middle of the table. I'll pick those up. Here's what I would recommend that you do tonight to study. I would look over the journal entries. I would look over the multiple choice questions. Yesterday, you guys were given the packet titled Unit 2 New Review Questions or something like that. Here's where I would start the conversation. I would start with question number 1, part C, and just go all the way through. For the kids that are at Southwest in the room with me, I would say by the end of this period, I at least want you to have finished off all of question number 1 and all of question number 2. Aaron, this question, like, you were born for this question, okay? And ideally, question number 4. Question number 4 comes from my friend Mr. Simler at North Central. So finish up question 1, question 2, question 4. If you have time, loop back around to question number 3. I'm going to leave the camera on. We're going to film because maybe I'll do something up here. But for the kids at North Central and East End, you might want to fast forward through the video and see if I'm actually getting back up to the board to do anything. Otherwise, turn off the camera, enjoy the ride, good luck on the test. We start Unit 3 tomorrow. Yeah, you can sit down at my desk. Okay, so you guys are ready?
Oh, yeah. What do you mean when you bring over the chair?
Okay, so if you're going to come over there to work with me, you're... I understand. David took control of the situation. Hey, we had to get
Wait, are y'all gonna start on multiple choice?
We're going to focus on the free response first. But Aaron, if you want to come on over and we can talk about multiple choice.
No, I was gonna do free response, yeah, but I was gonna stay over here tonight.
I want to focus on free response first.
Oh, okay.
Okay.
It says do friend right here with the
So I'm gonna go on page.
What is that free
No, I
Okay.
free response.
I'm not the one with that.
I don't have to do it.
And we talk about that in a little bit. I need to spend some time with these guys. Okay, so all these friends want to talk to me about free response? Okay, then I'm not going to look at the small board. And Stephen, can you just make sure that anything I'm showing here isn't on that camera?
Oh, isn't?
Isn't on the camera. Alright, so Andrew and Carmen, you guys are working on the review problems from yesterday? Friends over here are working on the review problems from yesterday? Friends over here want to talk to me about free response. I have to get the quiz back from you all. Okay. I have one. So what parts of the free response will we talk about?
Oh,
Okay. I got it. Alright, Colin, are you joining us?
People think it's going to be this, but it's reverse. You do it beforehand. This only happens if the customer is going forward, not backwards.
Okay, so let's start with part C. So part of the issue in part C is you want the equation of a tangent line. If you're going to write the equation of a tangent line, we need 2 things. You always need 2 things. 2 things always and forever. And those 2 things, you need a point. I gave you the point. Okay, I gave you the point. What I gave you the slope. So what I'm asking for, I want to be not too bad because I really don't want this to get picked up on the film. So we've got big F, which passes through the point -2 comes 5. That's the point. Your slope means big F prime. Well, what's big F prime? Big F is the antiderivative. Big F prime would be little f. So when I ask you for big F prime at -2, what I'm asking is, what is F at -2? So we're gonna get back to the graph. And what do we know about this graph?
Pretty right.
Okay, here I want to be careful. At -2, I can't read that, I can't tell you exactly what that means.
Which is why you have to use the equation. Don't eyeball it from the graph, use the equation.
Right, so that's why you're gonna get, what was it, 3 to the -2 plus 1 power? Minus 1. -2 plus 1, is that -1? So we get a third minus 1, -2.
Is that even realistic based on this graph?
Yeah. Oh, wait, no, because I need to read this. Just make sure it is clear. Just make sure it's super clear, maybe what I'm looking at.
Label it like.
Oh, Aaron, you can turn that off. Thanks. That's fine, perfect. Is it regular -2/3? Now that we've got the -2/3, we're gonna use the -2/3. Okay, this is your slope.
This one?
So when I want the equation of the tangent line, we're gonna say L of x is my slope, x plus 2 plus 5. You would get 1 point for coming up with the right slope, 1 point for coming up with the equation of the tangent. If you had, for some reason, -1/2 estimated from the graph, you get this point.
So it'd be over.
Because if you say L of x equals -1/2 x plus 2 plus 5, that would be a follow through. Because we're looking at the graph of little f, and what I need is the slope of big F. Right? The slope means the derivative. The derivative of big F is little f. Alright. We're good? We're good? Alright. So, now what I need is I need an estimate for big F of -1.5. The reason that you use the tangent line is the tangent line gives you a tool for estimating the antiderivative. But it's this value that I want, so I'm going to say big F is approximately what I get when I evaluate L as -1.5. But this is what I'm interested in. If all you do is show me L of -1.5, not going to do it. This is what I'm estimating, this is how I'm estimating. And so that's when I'm going to say -2/3, -1.5 plus 2 plus 5. Don't bother simplifying. Third one. And now the last part, underestimate or overestimate. Okay, but underestimate means nothing to me. I mean, like, it's a long write-up. It's the hardest point to earn out of the whole thing. You've got to think about where's the point that I'm using my point of tangency. What's the point that I'm estimating, and what happens on that interval? So from x equals -2 to x equals -1.5, what I care about is the concavity of big F. Well, how do I figure out concavity of big F if what I see is the graph of little f? On this interval, f is increasing, little f. If little f is increasing, how does that tell me something about big F? Big F is concave up, and we want to stay away from the word if. Big F is concave up. If big F is concave up, where are those tangent lines? They're all below the graph. So tangent lines are below the graph, which is going to mean an underestimate. Done and done. That's all of it. This is going to show up again and again. This is going to be okay. it to go over there, but I can't. Stuck over here in the corner. And once, what?
Oh, I thought you needed to grab some.
No, I don't wanna put anything on camera unless I really wanna put it on camera. Alright, you guys are good? And Giselle, we will definitely look and figure out what the missing assignment is. I'm wondering, is it the one that I just passed back, did I put like a grade with a question mark on there? No? Okay, we'll figure it out. Alright, you hear this? Alright, so now here's the thing. We've got a graph, big F. But the only thing that you have in front of you is little f. And they told you big F passes through, is it the point 0, -2?
Yeah.
Okay, good. Well, let's start there. My graph passes through the point 0, -2. Now you're gonna have to start telling me things about big F because of what you know about little f. So for example, if little f is positive, what do we know about big F? If little f is positive, big F is increasing. If little f is decreasing, big F is concave down. If little f has a root, big F has a horizontal tangent line. If little f has a relative max, big F, that's a tough one. If little f has a relative max, that means little f changes from increasing to decreasing. Not, not a point of tangent. If little f is a relative max, little f changes from increasing to decreasing. Big F changes from concave up to concave down. It's not point of tangency, it's point of inflection. Okay. So let's start looking at the graph of little f. You have the graph of little f in front of you. What are the things that you know for sure? I like to think about this in intervals. If I start over here at x equals 0 and I go forward from 0 to 2, there are some things that I know about little f. Little f is positive and decreasing.
Which makes big F concave down and increasing.
Big F is increasing concave down. Increasing concave down looks like that. So starting at x equals 0, going all the way until I get to x equals 2, I need increasing concave down. Where exactly is this point? I don't know. I don't care.
Yeah.
That's not part of the question. I'm looking at, are you increasing in a concave down way from 0 to 2? That's all I care about. Yeah. Like if you put it here, below the x-axis? Okay, so you said, okay, did you do it like that way? Okay, so what I'm looking for is your graph increasing, concave down. Increasing concave down? Yes. Below the x-axis, above the x-axis, way up here, I don't care. I thought at first you were asking me about down here. You couldn't be increasing and concave down if you get down here. We're just looking for a sketch of what's going on. So it'd be okay, why it has to look like something like this. Okay, give me another interval. From 2 to 3, what are the things that we know about little f? What does it tell me about big F? Little f is positive. Little f is increasing. Big F is increasing concave up. Draw increasing concave up. And that's from like 2 to 3, right? Now here's the thing. You have to start here. What if you didn't start here? What if you started like up here? That would mean that big F isn't continuous at 2. And what would we see on little f? Well, if big F has a jump, then little f can't be continuous. There's going to be a hole, there's going to be a jump. The derivative couldn't exist if big F was not continuous. So it has to be a continuous graph. You okay with that?
Oh,
Yeah, okay. Now, what do we know about big F at x equals 2 now? See if there's a point of inflection. So just label it, go on. Again, I don't know what the y coordinate is, I don't care what the y coordinate is. I care about this increasing concave down, this increasing concave up. I need to see a point of inflection, so make it clear to me that it's a point of inflection. Oh, you can turn it off, unless you're like
Swipe
standing
open
up
the
every
phone.
9
Swipe
minutes.
open the phone.
Okay. Next interval.
No, you swipe open. Next one is on 3 to 4.
Okay, now I want to be careful. From 3 to 4, 3 to 5. I would go from 3 to 4. Because from 3 to 4, there are two things that you know are true. Little f is positive and little f is decreasing. So I'm thinking about little f first. Little f is positive and decreasing, so big F is concave down and increasing. So I need concave down increasing. Concave down increasing ought to look like that. That's x equals 3, here's x equals 4. What just happened at x equals 3? Point of inflection. Okay? The reason, Celeste, I can't go from 3 to 5, on 3 to 5, you can say little f is decreasing, so big F is concave down. But I can't make the statement that little f is positive on that whole interval. I can't make the statement little f is negative on the whole interval. So I'm going to break it up into natural chunks. So from 4 to 5, little f is negative. Little f is decreasing. So we get over to big F. Big F is decreasing, concave down. So you show me decreasing, concave down. There's a relative mass. Okay. Okay. You solved for the integral. Wow, you were. Okay, but this is original work, and this is original work, and this is the. Okay. Okay, so you do something great. Which is partially correct. Okay. All right, so you guys are good? All right, so I'm gonna pick up the quizzes. Okay, so I'm looking, the pencil is the original work and the purple pen. Okay, pencil, yeah. You just circle it, draw my attention to it. Can you fix that, please?
What? Just
I can't look that way for too long. Number 4 is a good question to talk about. All right, Giselle, come on over. Hi, North Central and East End. I told you there wasn't going to be much of anything. I hope you're reviewing. I hope tomorrow goes well. Make me proud. All right.
Are you okay? To go to 4? 4 to 6? I know it's this packet, but I can look at because you know
It's called problem set 3 from the next one.
so the river that
That means, so here's the thing. If you can find it, I mean, if you turned it in, I would have graded it and given it back, right? I don't say ask back. If you can find it, give it to me. If you don't find it, talk to me. And most likely what I would do is just mark it. Okay, because obviously,
no,
As long as it looks
as long as it's increasing the company.
mine's correct and the ending here.
graph it.
It makes it so much harder.
Yeah, it's first world things.
I mean, that's, if you use virtual notation, you straight up. What did you grab?
That's exactly. I did. I don't know.
Oh, yeah,
I don't know. It's right.
Just for a second. So for all the friends in the room and online, that very, very first question that Ms. Cooper put together, and then I stretched a little bit. Part D, you're asked to come up with the equation of a tangent line and then use that tangent line to do an estimate and then indicate overestimate, underestimate. Gosh, we've done that so much. Part E asks you to graph a derivative. The thing that should be part F, but I forgot to put an F on there, please forgive me, asks you to graph the antiderivative, like the thing from the quiz that we were just talking about. I'll send you the solutions. I think the smart thing for you to do is make sure that you can do all of problem number 1. Really, I'd make sure you can do all the problems on here before you take the test tonight. All right, see y'all later.
I squished your head.
Leave it to the desk, please. Celeste, what are you doing?
I squished your head.
Oh, you were squishing my head. I'll squish your